So our first slide here is going to be in global trends in consumption. So first we're going to talk about the poverty reduction. There are approximately currently 840 million people who live in extreme poverty. Ever since the date of 1990, there were 1.9 billion population that were living in extreme poverty. Since then, there has been a 56% decrease in extreme poverty. And to define extreme poverty, it is defined as those who live per person under an earning wage of $1.9 a day, and this is assuming in US dollars. The middle class population in the lower income countries, also known as LICs, have increased between 18 to 50% from 1990 to 2015. And many of those who live in extreme poverty uh, often work in unsafe work conditions, and those may include the physically demanding agricultures, such as the hard labor, mining, and textiles. Some other vocabulary that you may also need to understand is lower class and middle class, which is defined here in the lower left, where those in lower class earn $2.15 a day, or those in middle class earning an average of $4 a day. Next, we're going to talk about the global growing middle class, and the middle class population as of 2009 is about 1.8 billion, while currently it stands at around 4 billion people. At the time of the textbook that was written, 2009, most of the middle class population was based in Europe, Asia, and North America. However, in Asia, it should be specified that it was still a growing population at that time. Many of which who were in the middle class were susceptible to unemployment, underemployment, and underemployment meaning those that are employed who may be not working to their fullest potential, and this may include the informal activities. Informal activities may include the following: ride sharing services like Uber, Lyft, home services such as cleaning, transportation, handiwork, freelance. Alternatively, it does mean that anything that is not officially taxed or does not apply to a pension, flexible part time or contract based work. Next, the new global middle class, also known as the NGMC, is the above is defined as the population who are above the poverty line, however, are still under the wealthy. And as of 2009, there is approximately 2.5 billion in the global population. To be defined as classed of the NGMC, the person must earn at least $12 a day or $3,650 to $36,500 a year. And the development of the NGMC comes from the new economic growth, urbanization, or tech development, with China and India actually leading the NGMC population by 50% in total. And next is the fragile middle class, which is essentially the people who are in middle class, however, are facing financial instability towards debt or falling towards the poverty line. Next, we have ecological footprints, which is defined as the hypothetical area of land required by a society, group, or individual to fulfill of their resource needs and assimilate all of their waste. And it's essentially a model in order to monitor the environmental impact. LICs or lower income countries have a smaller footprint due to their smaller rates of consumption. However, it is increasing due to new developments such as new industries. HICs have more of a disposable income, allowing them to spend their money more recklessly, as well as due to their more increased, free time. And LICs unfortunately don't have that privilege of having as much disposable income, so they are not allowed to spend that as freely. Alright. Next is water consumption pattern and trends. So about 780 million people do not have access to safe drinking water. And the increasing populations and the increased standards of living with our new global world is um, causing the higher demand for clean water. And we can actually see here in the graph on the left, the total of water here is actually 97.5%. That is actually made out of salt water or saline, while only 2.5% is fresh water. However, next you can see that 1.6% of the 2.5% of fresh water is locked away, and 68.7% is from the glaciers and ice caps, while 30.1% of the 1.6% is trapped in groundwater. In total, there is only 0.9% accessible to humans, um, with 20% in lakes, 69% in ground ice and snow, and 3.8% in soil. Water stress or water scarcity is mostly located in Africa, the Middle East, and Southern Europe, where in Africa often faces the climate change and droughts, and HICs are expected to maintain or increase their consumption of water over the next few years due to their new standards of living, and especially the standard of living from the new modern appliances including pools, washing machines, etc. And it is approximately 3 meters cubed a day that HICs will use their global consumption of water, while Asia is compared at 1.4 or Africa at 1.1. And most of the water located from Africa is embedded in agricultural products as well as virtual water, which we'll cover on the next slide. So virtual water is essentially the water that is transferred between one country to the next via exports. And those may include foods, agriculture, or manufactured goods. And virtual water is also included, of which that water is needed to grow or make those products, including those of which of physical labor, including processing, machinery, or irrigation. Some examples of processing and machinery may include those of water needed to wash fruits before processing to be wrapped and exported to other countries. And for those countries with limited water resources in, for example, Africa or the Middle East and Southern Europe, they can import goods to balance out their water exports, as many lower income countries may grow fruits or other types of agriculture to export to HICs, while they can import other goods to sustain their own virtual water balance. Next is the land availability and food consumption, where there's an increase in food intake over the past years as the world population increases. And food intake is measured in calorie intake or kilocalories for some countries. And land availability has declined due to many areas having the combination of land use changes as well as land grabs. And land use changes include the use for agriculture, forestry, and other human uses. And when I mention other human uses, that is in reference to such as building up new villages, cities, and as for agriculture, use for farming, and land grabs is a good mention as well, where land grabs are defined as when large corporations or companies acquire large areas, usually for agriculture and industrialization. Land grabs are similar to land use changes, however, it's a more specified term. So, for food consumption, the diets have changed over time from where often I would like to use China as an example, where in about 1950s, 1960s, 1970s, where farming was a huge industry, where grains and cereals were often what those people would eat. However, due to new living standards, more people have focused, especially the HICs, towards the food pyramid standards. If you're familiar, would be the lowest having um, the grains, milk, and meat type of diagram. And next is the consequence of natural hazards that are impacting the food consumption and resources, which are global climate change and land use changes, especially for biofuels. And just some vocabulary to keep the memory fresh is extensification. Extensification is expanding the area that is farmed. Multi-cropping, which is harvesting 2 or more crops a year. And finally, intensification, which means using a higher yield variety of crops, usually including GMOs. And some other ways of increasing food production may include reducing food waste and loss, improving food storage, in vitro farming, and vertical farming. Vertical farming is a good case study to use in your paper 1s and 2s, where vertical farming is essentially indoor farming, where plants are lined up either on shelves or hanged up on the ceiling as a type of micro farming. Next, we're going to discuss the consumption of energy. So, the global demand for energy has increased significantly since the 1950s, um, and it is predicted that the energy demand will likely increase by nearly 50% by the year of 2050, along with the development of industries, which will cause the increased consumption of energy. Additionally, the NGMC population growth, which, as mentioned before, is about 4 billion now, allows those to have more access to devices as well as appliances that consume more energy. And those include washing machines, television, handheld devices, etc. Next is renewable and non-renewable resources. So non-renewable resources are fossil fuels. Coal, gas, oil, those are usually what powers our man-made machines or other energy supplies. And it should be specified here that nuclear energy or nuclear power is considered as a non-renewable energy, as uranium is now a non-renewable resource. On the other hand, renewable resources or renewable energy include hydroelectricity, solar power, wind turbines, or tidal power or energy. Tidal and hydropower are similar, where tidal is specifically mentioning that turbines under seas or the use of dams, and renewable energy is sustainable as it is not depleting any type of resources, as, for example, as mentioned before, the use of dams, where the water is just flowing out to the ocean, or dams used for drinking water as well. Other alternative energy resources include nuclear due to the low carbon and low emissions rates. However, nuclear power is controversial due to the nuclear or radioactive waste, as well as the dangers of a potential accident. And a case study for this would be the 2011 Fukushima disaster in Japan, where an earthquake happened, large magnitude tsunami that essentially caused a full nuclear meltdown, which also caused a lot of radioactive waste to be flowed into the Pacific Ocean and as well as into the atmosphere. Next are the changes in demand. HICs and NICs, or newly industrial countries, are the major consumers of energy. However, patterns are expected to shift from North America and Europe towards the NICs due to the manufacturing and um, development of industries as well as transportation. On the other hand, as LICs develop, uh, there will also be an increase in their energy consumption as well. Okay, and section 2 that we have now is the impacts of changing trends in global consumption. Okay, the water, food, energy nexus. So here's a little graph about the energy, water, food nexus, also known as WEF nexus as well. So the nexus basically means that there are close links between these three resources: energy, water, and food, and one will some way impact one another. Water security is defined as access to safe drinking water and sanitation. Food security is defined as the availability and access to sufficient, safe, and nutritious foods to meet the dietary needs and food preferences for an active and healthy life. Sorry, it should be lifestyle. And it should be also mentioned that despite having food security in many of the higher income countries, many of us do take advantage of fast foods instead of actually having the nutritious foods to meet dietary standards, which is also one of the reasons for the case study of obesity in America as well as China. Energy security is having the access to clean, reliable, and affordable energy for cooking, heating, lighting, communications, and other productive uses such as office work. So the interactions between the water, food, energy nexus is that water is essential for transportation, mining, agriculture, or raising livestock. And for agriculture, 70% of the global water usage is mostly dedicated to agriculture and raising livestock. Next, energy is required to extract water, sanitize water, or sanitize other materials and resources, and distribution and transportation of water. Agriculture solely accounts for only 30% of the use of energy, while the global climate change also has uncertainties requiring adaptability for other industries as well. And here I've mentioned two case studies, which I will link in the slides later. So first one we have is Singapore's innovation for water security, where they reused wastewater and rainwater from industrial uses as well as domestics to create or reuse for non-drinkable water, such as watering their green spaces, or for some areas for the use of their toilets and other purposes as well. And this one I like more is the Netherlands, where they have a sustainability between their food and energy use. And Netherlands has a limited land resource. However, they have a very dense population requiring this type of sustainability. And this type of sustainability that they use is they use geothermal heating systems to warm their greenhouses in the winter, which means that they are reducing the dependence of fossil fuels. And this is also known as a closed loop system, where waste from the crops became their compost, while the biogas produced by those crops are used to power the greenhouse and their farms. This allows the minimization of waste, energy, and water use. And it is also an example of sustainable intensification, which means the growing of more food with minimal inputs. So next is the climate change influence on the nexus, which is the so there's climate change can impact the nexus both ways by reducing or increasing agricultural productivity depending on reasons, and specifically for the negative parts of the climate change such as droughts, flooding, and disease transmission from floods and other still water resources, unfortunately. And high temperatures will also increase the needs for irrigation, or as well as the treatment and distribution of water. While energy, many countries or agriculturals will have to depend on renewable energy resources due to pollution and the production of greenhouse gases. And for the example of climate change influence on the nexus is fish stocks, which is also mentioned in the Oxford 2017 textbook and study guide. High temperatures can cause the increased population, more breeding from fish. However, the downside of it is the algae contamination that comes in the oceans as well. So solid domestic waste, those of which of solid domestic waste of, I guess, recovering or reusing it to reduce climate impacts are the following from best to worst order: removal, reduce, resource, reuse, recycle, recover, and return. As for the main three, which I will cover here in the slide, is the reducing of the amount of waste produced, which producers will think more of the lifespan of goods as well as the packaging waste. Both producers and consumer will think of the packaging waste. Reuse of goods to extend their lifespan, such as the bring back schemes. Some countries in Europe or Australia, Canada, US, I know have bottle depots, or basically centers where you can return your bottles and other recyclable materials. Putting goods to another use, such as old clothes which may be teared or not wearable anymore, can be turned into cloths. Plastic bags can be used as bin liners. As for recovering the value, composting, incinerating waste for electricity, recycling paper, glass, and other recyclable materials. Composting can be used for recovery, such as being reused and put into a personal garden otherwise. And finally, the disposal of waste, which is the return part, returning back to the environment in a safe manner, obviously. And this one is the disposal of waste, putting in the landfills, which is basically putting waste in a hole and forgetting about it, or eventually incinerating it. And one good use of it is to turn it into an artificial here, seen on the right side of the screen. And this is actually a picture of Mount Trashmore, as they call it in Virginia Beach, where it is made a artificial hill. On the other side is a artificial playground, and all of this is made on top of a landfill. E-waste. So in Guiyou, China, also known as the e-waste capital of the world, and e-waste is actually a $25 billion business, or in the global industries. The American average of the yearly e-waste produced per person is actually 30 kilograms. Most of it from packaging and other um, types of waste produced, I guess. And in China, there is less than 5 kilograms produced per person in China. However, China does have a um, high industry in producing goods in factories and industries. E-waste is categorized as those of discarded devices such as phones, computers, and TVs. And unfortunately, more e-waste is produced in HICs as well, specifically in Europe and USA, um, due to new upgrades or new devices that are coming out almost every year. There will be new iPhones, new devices produced, which most people obviously want those new upgrades, leaving their phones to be discarded only after 2 or 3 years of use, on average, in America. While back in 2003, the average use of phones, their lifespan would be about 6 years, which is double of the current lifespan today. HICs often export their e-waste to lower income countries for cheap disposal and recycling, and those may include um, China's low wage but large workforce, which allows for cheap labor, while China actually imports about 3 million tons of waste plastic, on the other hand, not on e-waste, but just in general international flows of waste. 15 million of paper and cardboard, as well as many of those exported goods from China to Canada, US, and other countries as well. More of the waste coming back to them to be discarded. And in terms for e-waste, for those LICs such as Philippines and China receiving the e-waste, environmental damage and health risks are considered. Environmental damage, which include the toxic gases from the electronics and the chemicals that seep into the soil and water, which ultimately will impact the agricultural side in the long term. As for health risks, many of these heavy metals are cancer causing, may cause respiratory issues, neurological damage. As well, it should be mentioned in Guiyu, China, that the population actually has high rates of lead poisoning as a result of the e-waste disposed, cancer-causing dioxins, as mentioned, as well as miscarriages. As for the Basel Convention here mentioned below, um, it is a international law that essentially restricts hazardous waste exports, which many HICs, in order to export their e-waste to the LICs for cheap disposal and recycling, they will mislabel the e-waste as secondhand goods in order to bypass the hazardous waste exports Basel Conventional law. And the reason why it's mislabeled as secondhand goods is because of, for example, Apple's trade in some countries where you will be allowed to trade in your old devices in order to get some sort of credit for other Apple electronics. And these trade ins, many of the devices do not end up getting recycled or destroyed in their own California plant or the recycling plants. As a result, they actually take apart the phones and will erase data and pass on these small parts to lower income countries such as India in order to recreate or develop second-hand goods type of materials or phones which are reused from trade-in products. Okay, next we have the resource stewardship. So first, we're gonna discuss the negative, contrasting views on the population and resources. First, we're gonna talk about the neo-Malthusians, which are people who have a negative view of the growing population, in which the growth would eventually lead to a decline in living standards and eventually a world of turmoil, war, disease, etc., which is also known as the Malthusian catastrophe. However, they have proposed that positive checks be used, which is naturally increasing the death rate as the birth rate grows, such as famine, disease, natural disasters, including of which COVID-19 is a way that was a positive check where the death rate naturally increased as birth rate continues to grow in most countries. On the other hand, there are negative or preventative checks, which are to decrease the birth rate before the crisis point is reached, which is an example of China's one-child policy, where only one child was allowed per family, as a way to decrease the birth rate, not necessarily as the crisis point was reached, but at the time of the one-child policy, was that China was at a time of low food production, low agricultural production, and there was general stress and famine. The 1970 Club of Rome model. So there are 5 basic factors that determine and limit the growth. Again, this is the negative views. And those 5 are including population, agricultural production, natural resources, industrial production, and pollution. And this model suggests that food supplies would start decreasing from the year 2000, as well as the rapid resource depletion that would occur from the year 2000 as well. While the food supplies, this point is correct. Currently, the standing point is we are reaching the plateau of where food supplies are to start dwindling down. As for resource depletion, it is getting around there as well. However, there are new renewable resources that are used, which are keeping that at bay right now. And this is also a very important person that you should remember, and this person is Paul L. Ehrlich, who is a neo-Malthusian, and he believed that population control, the increase in food supply, redistribution of wealth will reduce the world population growth, and this was actually around 1970s, 1980s as well. And basically, the main point of Mr. Ehrlich is that he made a wager with a economist named Julian Simon on the price of 5 metals that they chose, and he bet that the price would increase due to the population growth and demand. I don't remember the exact 5 metals. One of them was copper, which was, I'm assuming, he reasoned that the demand would be from the creation of industries, as well as the increased development from LICs needing to use of copper, which is a relatively cheap metal at that time. And Simon, or Julian Simon, he bet that the price would decrease due to new tech development, which would allow for more efficient production of these metals. Ultimately, Ehrlich did lose this bet. And for our next slide, we have Esther Boserup, who is a Danish economist. Now we're moving towards the optimistic views. She does have an optimistic view similar to Julian Simon's theory of new tech developments, where she also believed that The population growth will stimulate new tech developments and research, thereby increasing the food production. And she also believed that efficient resources will be used, um, furthermore, to the resource stewardship, which will be mentioned later on in these presentations. As well as renewable resources will replace the non renewable resources, allowing for more food production. Okay, for optimum over and under population. So, optimum population is defined as the working population utilizing the available resources in order to produce the highest per capita return. However, overpopulation is where too many people or there is a excess of population compared to the resources that are to maintain the standard of living. Somalia is a good example. However, it should be mentioned that many countries in Africa that face these um, water crises do have a lower standard of living, droughts, and agricultural practices as well. While, on the other hand, underpopulation means that there are more resources than population, allowing many of these resources to be exported. And for this example of Canada, this was around 2013, where there was still a lower population. However, over time, of course, immigration from other countries have occurred. There are a high population of Chinese and Indians who live in Canada, which has since increased the population. However, as for this example of underpopulation around 2003 or 13, the Canadian government were allowed to export much energy as well as the minerals. And good example is the pipeline that was proposed about 10 years ago. And the pipeline basically uh, extracted oil from the prairies in Alberta, Saskatchewan, out towards British Columbia, where it is allowed to be exported towards Asia as well as the United States. However, now, of course, there has been a decrease, and I believe the pipeline has been temporarily stopped or paused for exportation, additionally, as well, due to the American tariffs as well. All right, the carrying capacity. So, the carrying capacity, the definition of that is the maximum stable population size in which the environment can support, and it is determined by the size of population, the level of resource consumption, tech development, as well as the level of wealth, specifying in country wise. And the newly industrial countries are NICs consume more resources, and therefore they have a lower carrying capacity. On the other hand, HICs have a larger carrying capacity as they export most of their waste or e-waste, as mentioned earlier, towards LICs in Philippines or China, other Asian countries who have a larger workforce to handle these cheap labor, as well as they import many of their products and agriculturals from poorer countries, Mexico, South America, as well as some countries in Africa, especially for fruits. And next is the resource stewardship, which is now we're covering the tragedy of the commons. So, tragedy of the commons is the term that is used to explain the lack of control over the way that common resources are used, those including the atmosphere, outer space, high seas, and the Antarctica, where basically no single country has an exclusive right to all four of these global commons. And here on the right, we have a little example of each four. So first, the atmosphere, which is the layer of gases that surround the Earth, and outer space, the region that extends beyond the Earth's atmosphere. High seas, which is essentially the international waters. International waters are those that are excluded from the Exclusive Economic Zone, also known as EEZ, which are basically the seas close to land. I believe it's about 250 kilometers of water that each country has around the border. And finally, Antarctica, which is the Earth's southernmost continent and their surrounding waters. And some threats that each of these face are the high seas face the pollution, overfishing, as well as climate change. Overfishing actually mostly comes from countries in Asia and Africa, where the fishing industry is a larger industry. Specifically, I should mention in Asia, it should be southern East Asia, such as Vietnam, Thailand, where the fishing industry is larger than the industrial industry. Um, sorry, I mean the manufacturers. So for the atmosphere, includes the danger of air pollution and greenhouse gas emissions from other countries, climate change, as well as ozone depletion. As for outer space, it includes the threats of commercial exploitation, such as mining, militarization, and space debris. And when it specifies the space debris, it should be mentioned that space debris includes waste from countries. Some countries have decided to, instead of exporting their waste to LICs, to send trash to space, causing space trash. Antarctica, finally, is facing threats of overfishing, climate change, mining, and tourism. Currently, there is not as big of a tourism industry in Antarctica. However, many scientists are conducting research in the area, which is impacting the, I guess, tragedy for Antarctica. And for resource stewardship, earlier I forgot to mention that it is defined that resources are to be used in a way where it will be available for future generations. And the term tragedy of the commons, in order to explain this concept, is if a country takes more fish from the oceans, which is, again, excluding the EEZ, Exclusive Economic Zone, the seas close to land, the tragedy is that, the profits that if a country takes more from the oceans, their country's individual profits will increase, while the other countries will face the tragedy, which is the feeling that they have to catch more fish in order to match the scale of development within that country. Former countries that have exploited this type of concept is the Americas, United States of America specifically, where they have used the excess energy of fossil fuels. Okay, the next one we have is circular economy. All right. So the circular economy, it is defined to preserve the natural capacity, optimize resource use, and reduce the losses of materials by managing finite stocks and renewable flows. And the main concept here is to end waste and pollution by reusing materials and products, as well as the regeneration of nature, which will allow for more sustainable environment and economic development. So the circular economy has two different types of cycles. One is technical and the other one is biological. So again, previously mentioned, technical cycle would be something that is recycled, reused, repaired, or remanufactured. As mentioned before, Apple trade-ins is an example of reusing and remanufacturing. On the other hand, we have the biological cycle, which is where biodegradable products are returned to natural environments. As mentioned earlier, the Netherlands Sustainability Food Energy Nexus case study, where biogas and composting is used to energize their greenhouse, as well as reusing the materials for sustainability. And the case study here for the circular economy is in 2016, France had made it illegal for retailers to throw away food, and this one is more for food waste. And on the other hand, we have in 2021, where in China there was a ban for competitive eating and the sharing of binge eating videos, as it determined that there were often an excess of food waste as well. Food waste, I think, in Japan, they also have a penalty, as a matter of fact. I'm not sure which year they proposed this law. However, Japan does have a penalty for food waste, where the amount of trash, when categorized, they have a system where they categorize on landfill trash, recycling, and food waste or composting, the green bin, where the food waste, as it will be tagged when each household throws away their food waste, it will be put into a government system where at the year end, each household will be fined for the food waste that was wasted throughout that year. And finally, we have the Sustainable Development Goals, also known as the SDGs. There are 17 World Sustainable Development Goals here on the right, as you can see. And the goal for these 17 World Sustainable Development Goals are to the goal is to have peace and prosperity for our people and the planet. This was set in 2015, and it is expected to finish on 2030, or expected to reach by 2030. And these SDGs are meant to replace the 8 Millennium Development Goals, or MDGs, formerly from 2000 to 2015, which challenged world leaders to combat poverty, disease, illiteracy, gender equality, and environmental degradation, which ultimately these 17 goals will depend on the management of population and resources. And it is for these 17 development goals, each from last MDGs, same one here is no poverty for the first one. Second, zero hunger. Third, good health and well-being. Fourth, quality education. Fifth, gender equality. Sixth, clean water and sanitation. 7, affordable and clean energy. 8, decent work and economic growth. 9, industry, innovation, and infrastructure. 10, reduced inequalities. This was similar to the gender equality, or I think it was women, allowing women to have equality in the MDGs. 11, sustainable cities and communities. 12, responsible consumption and production. 13, climate action or climate change actions. 14, life below water, and that is considering the oceanic species. 15, life on land, having a sustainable environment. 16, peace, justice, and strong institutions. And 17, finally, is the partnership for all 17 of the sustainable developmental goals. Despite this being set for the year of 2030, which comes in about 4 years, many of these goals are harder to reach due to different country policies, as well as the governments that run their countries, such as America, which is causing a lack of partnership for these goals due to their tariffs imposed from other countries. And that's it. Does anyone have any questions for Unit 3?